This video is about how to integrate something. Well, integration is just a word for the opposite of taking the derivative of something. So some people call integration anti-differentiation, which means the opposite of doing a derivative. So you might remember that the derivative of x squared is 2x. Well, that means that there must be some sort of operation that I can do to 2x to get back to x squared. And what that would be is the integral. If I take the integral, which is this symbol, it looks kind of like a curvy S, the integral of 2x with respect to x. This part is just not really part of the integral, but it just tells you which variable you're integrating. So don't forget to leave this off, but if you leave it off, you'll still be able to do the problem. You just won't look as smart as you should. So the integral of 2x, which is what my answer was over here, I have to think of this as what function would give me an answer of 2x when I take the derivative. And so x squared would be my function. So if the derivative of x squared is 2x, then the integral of 2x is x squared. Well, somebody might say, well, wait a minute. The derivative of x squared plus 8 is also 2x. And that's true. And as a matter of fact, there are infinitely many of these that I could make, x squared plus 3, x squared plus 11, and so on. That would give me 2x for a derivative. And so we need to remember to put plus some number. So the integral of 2x is not just x squared, but x squared plus any number. Because remember, the derivative of any number goes to 0, which would make a 0 here. So let's look at a picture of why you need the plus c. So it's really hard to draw with this, but let's say this is x squared and x squared plus 1 and x squared plus 4 or something, 3, something up here. You'll notice that the slopes are always the same at a particular x-coordinate. For instance, the slope here is 0 and 0 and 0. So this says the derivative, or the slope, of x squared is 2 times whatever x you're on. So the slope here is 2 times 0, which is 0. Slope here is 0. Slope here is 0. So that means for all of these green lines, the slope is 2x. So the derivative of x squared is 2x. Now, look here. The slopes here are all the same also. So at this particular x-coordinate, the slopes are all 2x. Let's say this is x is 1. Or 1/2, or something like that, whatever x-coordinate you're on. 2 times a half would give me 1, and same here, same here. So you can see that as you go up this line, these slopes, especially if all this was drawn perfectly, this looks like it's leaning back to the left, but anyway, as you go up the line, the slopes stay the same. So that's why it doesn't matter how far you shift this up or down, which would be where the plus c comes in. The slope will be the same at that particular x-coordinate. So there are some integration rules, or some anti-differentiation rules, and I'll write them down and we can look at them. So the first integration rule is a power rule. Remember, when you're taking the derivative of like x to the 8th, you would bring the 8 down, or in other words, multiply by 8, and then you'd rewrite the x and you would knock one off this power. Well, to do the integral of 8x to the 7th, we know we should get back to x to the 8th. And let's follow this rule to do that. Okay, so let's integrate 8x to the 7th with respect to x. To do that, you rewrite your x. Now this says add 1 to the power. So instead of writing a 7th power, I need an 8th power. You'll notice that's what I need, but here's why. If you differentiate x to the 8th, you knock one off the power. So to integrate x to the 7th, remember integration is the opposite, so we do the opposite, so we add one back to the power. And to take the derivative, we multiply by the power up here. So that means then I probably need to then do the opposite of that, which would be to divide by my new power. And notice I had this 8 already in here. So I rewrite that 8, I rewrite my x, I add 1 to the power, that's what this part's all about, and then I divide by whatever that thing was that I created right here. And you'll notice these will reduce. I'll get back to x to the 8th. Now the only thing I'm missing is this could be x to the 8th plus anything, any number. So don't forget that. So that's how you do the general power rule. Sometimes the general power rule is presented in a strange way. So here we have two cases where I'm going to still use the power rule, but I need to remember how to transform a root into a power. So I'll think of this one as x to the 1/2 dx. So my answer will be add 1 to the power and divide by 3/2, which is actually like saying multiply by 2/3. And don't forget the plus c. And over here I'll think of this as 10x to the -2. So I'll add 1 to the power, which would be -2 plus 1 is -1, and I'll divide by the new power, plus c. So -10 over x plus c. Remember, because you move this to the bottom. Okay, so that's the general power rule for integration.